Welcome to No Diagnostic Required, the companion show to the C++ Annotated newsletter. This is the third episode, so that's episode 2, of course, and the first of 2021. I'm Phil Nash, developer advocate at JetBrains. I'm joined by my co-host, Anastasia Kazakova. Anastasia, how are you this year?
Good. Actually, back to work after the very long holidays here in Russia.
Well, that's good, because we're all very, very serious here at JetBrains.
Oh, yeah.
Always, yeah. So anyway, this is actually our January episode, and we were totally intending to record it in January, but you know how these things go. But, better late than never. And we're going to kick off, actually, with some news from Microsoft land. So, Anastasia, do you want to take this one?
Yeah, let's talk a little bit about the tools. And our first news is actually faster C++ iteration builds in Visual Studio. So Visual Studio team recently posted in their blog about speeding up the inner loop, the edit, build, debug loop. And the improvements were done in two directions. The first one is to PDB, to the program database creation, and debug interface access algorithm, which were improved. And the main effort, I would say, that is to avoid search by relative virtual address by caching the result of the previous request. And this caching gave them a very good improvement, I would say. So they reported something like double speed up of initial PDB load and up to 1.5 speed up for full linking, and the same in many other places. And I would say I was impressed because you probably know that we have our own LDB-based debugger for Microsoft toolchain, and we were struggling with many similar issues, and we were investigating many ways to improve. And so this was really interesting findings. And also the second direction they took was the better worst-case incremental linking, because when you do the incremental linking, there is always a worst case when you just fall back to the full linking. And for huge projects, the problem is that the incremental linking, which falls back to the full linking, might get even worse than just the full linking. Funny enough, but yeah, they were trying to improve that case as well, also taking some caching as an idea. So the idea was to cache the results of the earlier debug information generation, which actually gave them a very nice 2 to 5x speed up. But of course, there are downsides, like the PDB file becomes larger because it now stores the cache, and the first clean link of the incremental build takes longer. But still, a very nice improvement, I would say. And the way I actually noticed the news was that Aras from Unity, in his Twitter, he pointed to that news from Visual Studio, and he noted that in Unity they were using fast link. That's a way to improve linking by keeping debug information in the original object files. And they had issues with the third-party code, which was not understanding the debug info format. So they moved away from that with Visual Studio 2019, and they were suffering from the slower debugging. And they were really impressed with the optimization. And as far as I got the linking, a full Unity editor in release takes something about 20 seconds, which is a huge improvement to them, I would say. And they can now avoid the fast link, which, as far as I understand from ours, they kind of like a lot. So yeah, that sounds nice. And you can go through the details in the Visual Studio blog if you would like to learn more numbers and more, techniques, what they exactly were doing there in terms of the algorithms.
Yeah, it's easy to underestimate just how much link times can affect your overall build times.
True.
Previous job I had, to be fair, we had a lot of template code, and that was mostly my fault, to be honest. But the trouble with lots of templates is they tend to instantiate lots of the same types in different translation units, and then the linker has a responsibility to deduplicating all of that, plus lots of other things. And yeah, link times are really a killer for us, especially for incremental builds. So it's really good to see, such big improvements on link times from the Microsoft compiler here.
Yeah, that's true. Let's move forward with some more tools here. As we say, we were kind of busy in JetBrains, so we started the All Access program for CLion for 2021.1. And the biggest thing, which already entered the preview, so you can try it out, is the global data flow analysis. So the story is that previously we had local data flow analysis, which can capture actually a lot of things like enrichable and unused code and some potential dangling pointer and all the similar stuff. And last year we moved the local data flow analysis to ClankD-based engine, so it's now like kind of more accurate and performs better. But then we added the global DFA, which is a interprocedural data flow analysis. So it works inside the translation unit. And it gives you much more information because of that. So it's not just like local to the function body, but it's the whole translation unit. So for example, it can capture the like dangling pointer when the pointer is cleaned in a separate function, which is much more than just, capturing a dangling pointer inside a function. It captures the dead code when the function call is only happening under, for example, always false condition, and then the function body is a dead code. Null dereferencing also in the condition when the actual like null assignment happens in some separate function and all this stuff. But also, in addition to enriching the current inspection, it also brings some new inspections like enrichable call sites when all function calls are enrichable in translation unit, or the constant function results and constant function arguments. This is actually kind of cool. Interestingly, like I would personally expect that the analysis is much slower now because it collects lots of information about the translation unit. And indeed, so we measured that the first step, which is the collection of the relations, is kind of a little bit slower. But because of all the optimizations inside the next step, which is the biggest part of the whole analysis, the calculation of all the resulting relations is actually faster. And moreover, the timeouts for data flow analysis, these are the timeouts which are happening when the analysis is just canceled automatically by the IDE after the 5 seconds default delay. The number of these timeouts actually decreased. So we produced a few like measurements with some nice charts in the blog post, so you can check them out and check the analysis. But I would say the result is actually very, very impressive to me. We're still on it, so we're still like tuning it, but I would assume lots of goodies inside this global DFA inside CLion. So yeah, give it a go and let us know what you think. If it captures at least one real dangling pointer for you in a production code, I would be super happy, I would say.
It's really good to see so much work and effort going into this. It reminds me of a few years ago when I first saw Herb unveiling the core guidelines. And one of the promises was that we would be able to just deal with raw pointers most of the time because analysis tools would be able to catch when we had dangling pointers and things. And subsequently we sort of backed away from that a bit because it turns out to be really hard to do that in the general case. But it's obviously a really valuable thing to have built into our tools. So anything that we can do to make that a bit closer to reality is got to be a good thing.
Yeah, that's true. So yeah, and actually that was mostly about the tools. And now maybe we can move to some new goodies in the language. So what are the news, Phil?
Yeah, so since the standards committee has moved online to deal with the pandemic, they've actually also moved the mailings that were usually just before or after the committee meetings. They're now monthly. So we have a January mailing, and obviously there's quite a few papers in there, about 30, I think. So we're not going to go through them all, but just picked out a few that I think would be interesting. The first one actually, it's not a new paper. It's been around since 2016. There was actually quite a good episode from the author on CPP Cast a few years ago. I'll try and put a link to that in the show notes. Just going into what this is, but this is a stud colony, and it's a new type of container. This is on revision 12 now, the paper, and it's interesting. This particular revision doesn't really contain a lot of substantial changes. It's just a fixing up things here and there. So it seems to be, getting to that point. We're just polishing it, hopefully ready to be approved. I've been hearing good things about it, a lot of interest in it. But what is a colony? Let's say it's a container type. In many ways, you would use it very similarly to how you would use a vector. So we think of vector as like this default array type container where we just want to put objects in and we're not worried about associating it with other types of data. But it has a few problems because when you push things in, if it reaches the capacity, it's got to reallocate all of those elements. That means you've got to copy them as well. So, well, first of all, the items had to be copyable, but if you have pointers or references or iterators into any of those elements, obviously they become invalidated. And that may not be what you want. You may want things to just, once they're in memory, they just want to live there. And of course, you can put them all in shared pointers or something, but then you've got the overhead of the individual memory allocations, as well as the pointer management and so on. So, yeah, there's not really a very satisfactory way of doing that, given what we have in a standard today. What Colony does is it doesn't promise contiguous memory. So if you need contiguous memory, that's out. And ordering is not necessarily preserved as well. And you'll see why in a moment. So it would allocate memory in blocks at a time, chunks at a time, and then add things in, much like a vector, into each block. But if you delete something from a colony, it just marks it as removed and gets skipped over. And in the classic colony pattern, every missing spot in the colony will have an individual flag. But in the proposed version for C++, if there are several consecutive slots to be skipped, it just records that it's got to skip n number of slots. So it's a bit of an optimization. So a few little optimizations like that. Say it's on revision 12 now. It's gone through quite a process of improvement, and a lot of people interested in it from particularly games background, that they're really interested in this. But it's actually quite a useful general purpose facility. So you get most of the cache locality benefits of vector. Everything is still fairly close together in memory. And another thing that's an optimization for this particular proposal is having removed something from a colony, and you've now got this free space in there, if you then insert a new item, rather than putting it on the end, it will put it in the first available slot. And that's why I say ordering is not, you've got to give up your ordering constraints in order to achieve that as well. But that means that everything's going to be close together, particularly when you're iterating. There's only going to be a few spots where you may have to skip from one cache line to the next prematurely. So it's almost as good in that respect as vector, but you get all of these benefits of things staying in a fixed location in memory. So you can have pointers, iterators, and so on not being invalidated by mutating the overall container. So really useful. And it doesn't actually take that long to explain. It's actually fairly simple. But what I found is every time I hear about it, I think, oh, yeah, that makes sense. I understand that. That sounds really useful. And then the next time I hear about it, I think, so what's colony again? So I've tried to explain it now. So
yeah, we'll see.
yeah.
I'm actually wondering, you mentioned that it might be interesting to the game dev. So taking into consideration that they're mostly with arrays as their main structure, as their main container. So how would they feel about the colony? So would they maybe adopt it in some way?
Well, I think this has mostly come from the game developer community. The thing with game developers is they tend to build their own containers again and again and again. And this is one of the things that they build a lot. So it makes sense to look at existing practice and say, this is something that's going to be generally useful, let's standardize it. But most of that experience, as far as I understand, has come from the games industry. Because you do have like game objects that pop up and then they last for their lifetime and they go away. And of course you could create individual blocks of memory for them, hold them in pointers. But as I said, often you just want to have some array of these. That doesn't matter where they are, doesn't matter how they relate to each other. You just want to put them in there and they sort of live in that colony. That's where the name comes from.
Yeah, that's true. And they reuse the memory usually, like not.
Exactly. That's sort of not part of the generic pattern, but this particular proposal does allow you to reuse slots that have been freed up that way.
Yeah, wondering if there is anything similar in Electronic Arts STL version, similar to the colony. Not sure.
I haven't
don't
looked.
remember.
Quite possibly, but no idea. Be interesting to find out.
Maybe some of our listeners knows.
Yep. Okay, next proposal to look at is P2232. Now, it has the title Zero Overhead Deterministic Exceptions Catching Values. If that sounds familiar, it's because P0709 is Zero Overhead Deterministic Exceptions Throwing Values. And that similarity is deliberate. This is a bit of a play on that, or more of an answer to that, because P0709, which is something I've talked about a lot before, is a proposal for a new form of error handling that looks very similar to the exceptions that we have today, but works slightly differently. It's got slightly different syntax, slightly different constraints and guarantees, and it's meant to address some fundamental needs that have been identified. Now, P2232, it plays on that title because it's trying to say, actually, we can get most of those benefits that we wanted from P0709, but without new syntax, without having to do anything different, just by optimizing the infrastructure that we already have. And it's a proposal for that. But what's interesting is we talked last month about Boost Leaf, which is an error handling library that's just been adopted into Boost. This paper's by the same author, and it's basically taking the ideas from Boost Leaf and saying, what if we bake that into the language? What would that give us? What could that look like? And the idea here is that when you catch, because we talk to catch exceptions by reference usually, if you catch them by value, he's saying, well, then these new guarantees would kick in, where exception objects are created in thread local storage. In fact, there's already thread local storage involved in exception handling today in most implementations. So this is not really anything that new, but the object itself would be allocated there. And all that's passed down the stack is just the bit that says whether something failed or not. And that could potentially be passed in the same register bit that P0709 talks about. So almost no overhead, effectively no overhead on the stack. No overhead in the happy path case, so same as exceptions today. But in the case where an error is thrown, there's also much less overhead because you don't have the dynamic allocation and the RTTI to look them up, because you're dealing with values now. And there's some implications to that. You have to deal with slicing instead of object hierarchies. It's all dealt with in the paper. It's actually quite interesting. I to lay my cards on the table, don't agree with all of it. I'm a big fan of P0709, as most people that know me would know. But nonetheless, some of the ideas here, and of course in Boost Leaf as well, are very interesting, and definitely we should be paying attention to them, especially since even if we do go down the path of P0709, we're still going to need to live with today's exceptions. And if we can optimize that further, that's also going to be a good thing. And maybe we don't even need to do that. So yeah, I'm interested in this proposal, even if I don't entirely agree with it.
Yeah, I'm wondering how many zero overhead deterministic exceptions stunting proposals are there right now in work.
Yeah, it's an interesting problem because one of C++'s core tenets is having zero overhead abstractions, whereas exceptions, which are also seen to be fundamental to C++, we say that they violate that principle because, at least on the error path, they have the overhead, non-deterministic overhead of allocations and RTTI. So this is why it's something that people have got very interested in, because it's really trying to reconcile.
Yeah, but that was the reason why the people were not using them. Maybe this will now move them to actual usage. I mean, like, quite many people are like staying away from exceptions exactly because of that reason. I mean, like, right. And that was the whole goal of all these proposals, I guess, just to resolve that.
Yeah, to unify the community was one of the claims of P0709. Interestingly, this one, 2232, tries to play on that as well a bit and say that, the claim is made that the community is fragmented by these different error handling techniques, so we'll solve it by adding another one. There's an XKCD reference in there as well, but I won't link that one for now.
Yep.
Anyway, the next proposal to look at is P2168, std generator. Well, there's a full name, but std generator is all you need to know. So we've got coroutines in C++ 20, which is great, but just the language features, really. to make coroutines really work, you need library support as well, and it didn't make it in for 20. So there is a GitHub repo from Lewis Baker, CPP Coro. You hear it mentioned a lot. We'll put a link in. This is basically the sort of de facto coroutines library that you should probably use, at least as a reference. In fact, that's the idea. It's meant to be a reference for potential standardization for a coroutines library, because coroutines are more like a construction kit for coroutines. Just the language features and the nuts and bolts and the hooks. You actually need to build the coroutines themselves for different purposes. One of those purposes would be a generator. It's probably one of the simplest ones, which is really just like a lazy producer of values. So rather than having to construct eagerly some array or vector or colony of values, you construct them on the fly, but you can work with them as if they were a container. So ranges already gives you a way of doing this, and that's important. So this is a library feature to give you generators with coroutines, which works with ranges. So those two things work well together, which is quite nice. And another interesting feature of this is that it can be recursive. So it can call other generators on the same type, including the same generator. So it can actually refer back to itself. And there are some reasons that could be useful, all got into in the paper. So they thought through all of this. The proposal is from Lewis Baker, the author of CPP Coro and Coroutine Jabot. So it's got the right heritage. So I'm suspecting this is going to sail through the standardization process, make it into 23. I don't see any reason why that wouldn't. It's really just the first step, though. There's other more ambitious types of coroutines that we're waiting for as well. But it's good to see that process start and getting this in the process.
Yeah, true. I think like so many people are excited about the coroutines, but they do not realize there is still a huge bunch of work to be done. I mean, like this one.
We actually had a talk on coroutines at the last C++ London. I'll put a link to that in. And it was I think a 90-minute talk. And a lot of people who are, well, you consider them experts at C++, many on the standards committee. You can see that a lot of them were still struggling to follow some of the details of how coroutines work. It's going to take a while for us to really fully embrace them. But at the moment where it's all nuts and bolts, it is really only experts that can work with them. And even then, only a few of them. Once we get these libraries that will make it accessible for application developers, that's really going to be when we start to see coroutines adoption, I think. Yeah,
that's true. We actually started looking at coroutines in our tools. I mean, like we just opened, maybe a couple of hours ago, we just opened the ReSharper C++ AP where we added the postfix completion for coroutines, some coroutine-related postfix completion. So this kind of small step, but still very nice. So yeah, coroutines are coming.
Absolutely. Yeah. Not avoiding them. Talking of not avoiding things, safety and security is definitely something we can't avoid. But C++ hasn't got a great reputation in this area, although it is a desirable language for many of the systems that actually need to embrace it. It's like a bit of a paradox, really. So P2272, which wasn't in the January mailing, it was actually in the December one, but we didn't talk about it then. I just thought it was important enough to bring it forward now. Is actually a proposal to create a review group within the committee, drawn from industry experts, by invitation only, at least initially. So this is not just like anyone can join and just say, yeah, I know all about security. No, this is people recognized as being experts in these fields are going to inform and advise the committee, review papers that may have an impact here. And particularly in C++, one of the strengths of C++ is embracing things like undefined behavior for performance purposes, where, if you don't actually touch it, you just allow it to be there, then that's great. But that opens it up for, well, what happens if you do actually hit it? Because, no code is perfect. So a lot of these reviews will be around, how can you make those things safe while also retaining that core tenet again of zero overhead abstractions and not paying for what you don't use. So that raw performance of C++, while also being safe and secure. That's the magic bullet really that we're aiming for. So great to see a review group being set up by Matthew Butler, who's proposing this, who is definitely in that domain himself. So I hope he knows what he's talking about, because it's definitely not my domain.
Yeah, that's very interesting, actually. I'm wondering what exactly they are gonna do. I mean, like, will they just review and advise, or just bring some new proposals focused on safety, or just revise some, I don't know, old practices?
So my reading of the paper is that they are just there to advise and review papers that are proposed rather than bringing forward papers of their own. That doesn't mean that they won't ever write papers, unless it's explicitly disallowed, but I can't see that happening. But I think certainly the intention is for it mostly just to be an advisory role.
Okay.
But yeah, that's what we need.
Yeah, that would be very interesting to see how that work out.
Yeah, and obviously it's just a proposal at this stage, as all of these are. None of them are in the standard yet. None of them have been accepted at this point. That's the purpose of this this section, just to show what may be coming down the road, and hopefully has a good chance of doing so, because these are all things that I certainly support, with the possible exception of the error handling one.
Yeah, true.
Okay, well that's all the papers I wanted to talk about. Did you want to start telling us about conferences and events that are coming up?
Yeah, let's talk a little bit more about the communities and some community events. Even though, that's another year of many things happening just online. And ACCU 2021 will be online, so March 9 to March 14, including pre and post conference workshop days. But I would say a very good deal, because it's like something about 50% discount on the usual fees, and the tickets are already on sale, and also the schedule is announced, so you can go on and check the schedule and buy a ticket. And I was in the program committee, so I would say that was a tough choice to select all the talks, because to tell you the truth, there are lots of talks on C++20, and there were a lot of people collapsing on the same topic. I mean, I've seen many times when the same people were submitting very similar topics on some new C++20, and we had a very tough choice to select one out of 2 or 3. That was really tough, but now the program is packed with lots of things from C++20. I think this is maybe the first time I see the ACCU so much focused on one standard inside the program. But also, it's not only about the C++20, and even not just about the C++. So, as usual, ACCU is a lot about the general programming techniques and good practices. So there are lots of these things as well. And the keynote speakers are Kevin Heaney, which I loved a lot. So I would be really happy to listen to his keynotes, and Patricia Ass and Sean Parent. So lots of good things there. One side thing here is a very sad news regarding the Russell Winder, who was actually a conference chair for ACCU for a very, very long time. The role moved recently, several years ago, to Felix Petriconi, and Russell actually has passed away, and that's a very, very sad news. I would say, to me, Russell brought me personally to ACCU, and I always used to joke that there is no programming language, it doesn't exist, if Russell is not coding in it, because he was coding in everything. And yeah, it's really sad he's no longer with us. So there will be the first ever ACC online without Russell. And I pretty much sure will remember Russell for his contribution and the passion and the energy. And we send our sincere words of support to his family. But let's move to another conferences. So we have also C++ Now 2021, also unexpectedly online. I was not expecting that actually for C++ Now, but it is May 2nd to May 7th. So the registration open and the call for submission, they both are open now. And C++ Now is known as a very academic and expert-like event. So probably due to its roots in the Boost developers events. And there's a nice, fantastic week in Aspen, Colorado, fully packed with really hardcore C++, when at 7 o'clock in the morning, you meet a group of people coding in a library, and at 10 p.m. in the evening, they're still coding the library. And in between, they did a couple of talks and lightnings. And I think this will be kind of different this year. What do you think, Phil? Do you plan to submit, by the way?
Well, okay, two very different questions there. It's definitely going to be different. But I think possibly in a good way, because, as you say, it's got a bit of a reputation as an experts conference, but it doesn't mean it's not a welcoming conference. I've met quite a few people that are quite new to C++ who have gone to C++ now in the past and had a really great time and really been drawn into the community. But it's also quite an expensive one to get to, usually, being up in the mountains at Aspen on a ski resort. And even though it's off-season, the hotel's still quite expensive. So especially traveling from Europe or further afield. Not everyone's been able to get there. But of course, this year those barriers are down. So it could well open up to a lot more people. And that's going to be an interesting dynamic. If a lot more people meet that sort of experts type of program, it's going to be interesting to see what that's like and what that results from.
Yeah,
but it is
and
true
no bears.
Right, no, well, probably no bears, but we'll see. I mean, on the internet, who can tell? But it is true that the venue in past years has definitely been an integral part of the experience. So, we'll definitely lose something. We're losing something from all of these events that they've moved online, but let's not forget what we're gaining as well. So I'm looking forward to seeing what that's like, and I do intend to submit something, but I haven't quite pinned down what yet. But I've still got a couple of weeks.
Yeah,
plenty of time.
February 14th, I guess, is the date.
I believe so, yeah.
Yeah. Okay, thanks. There is also one more event, and I think, Phil, you know better about it.
Rewinding, we've forgot a bit about C++ now. On the homepage, there is there's a video from taken from past events. Just advertising what it's like to go there, and as I say, emphasizing that location, which is actually quite special. If you do watch the video, though, it's interviews with people that are attending and speaking there. You might recognize a couple of the characters.
Who's that?
We both feature in there, so you'll have to watch the video to find out what we say. But spoiler, it's all positive stuff.
Yeah.
So the next conference to talk about, I'll talk about because it's my conference, or at least I'm the organizer. So C++ on C. It's going to be the third year. We've only actually had 1 year where we've met in person, sadly. But last year we moved online, and that was definitely, I would say, a qualified success. It was one of the first conferences, certainly in our community, to move online. So we were learning a lot of stuff as we went along. But a lot of people did feel it was like one of the first events they'd been to online that managed to capture some of the experience of actually being there, meeting people in person. Because a lot of what you go to a conference for is not the sessions, it's what goes on between them. And since then, a lot of other conferences have perfected this art. We're getting better at it. But as we go into the second year of doing that, well, I don't know. I personally feel like we should try to do something a bit different, try to embrace this new format. So for C++ on C 2021, which is going to be online again, we're actually going to move to put a bit more emphasis on the workshops. And if you've not really attended the workshops before, you may think, oh, that's a bit of a step back. But actually, no, quite the contrary. In fact, the workshops seem to have been doing really well during this sort of shift online. So while the numbers are down a bit because people are just reticent to commit to things that they don't know, the people that actually attend workshops, they've been getting a lot out of them. In many cases, actually more than they would in person, because there's just different opportunities to interact. So I wanted to give a bit more of a showcase for that. And rather than just the traditional, you've got to do a workshop for a whole day or 2 days, actually have slightly smaller workshops, maybe half-day workshops, as well as the whole day ones. So you can actually get a ticket for, say, 3 days, and you can choose which ones you actually want to attend. You're going to build your own set of workshops. So somewhere in between the traditional conference and just workshop-based event. There will be 1 day of just normal conference talks as well. So if that's all you're interested in, you can still do that. And there's definitely something to be said for that. But I think just those talks over several days starts to get a bit too tiring in the online format. So that's what we're experimenting with this year. No more details than that just yet. Well, there is a blog post with a little bit more, but dates and more concrete details will be announced soon. But I just wanted to pre-announce that because I'm sure people are starting to wonder what's going to be happening this year.
Yeah, this actually looks very similar to what NDC TechTown did in September in 2020.
Yes, they did. In fact, I gave a workshop at NDC TechTown.
Yeah, me too.
So, yeah. And I thought it went really well. Overall, there were some things that didn't go as well, some things that did. They were one of the first to try that format, I think. So, yeah, we'll have an opportunity ourselves to iterate that. But I do think that is a better fit for the times that we're living in right now. And hopefully it's not going to be too much longer before we can meet back at the physical events, because there's definitely something that I'm missing. But let's also embrace what we can get for now.
We'll run out of ideas of a new format.
Yeah, I haven't got many more up my sleeve, so this one better work.
Yep.
Talking of new formats, we were talking about all the new podcasts that have been emerging. We're one of them, of course. Last time we talked about Two's Complement, so the new podcast from Matt Godbolt and Ben Rady. Matt Godbolt, of course, particularly famous in our community for Compiler Explorer. Well, they've actually had 4 episodes now. And initially, I sort of categorized them as being a bit more about games development, because they mentioned that a bit in the first episode. But actually, they seem to have evolved more in the direction of testing, the latest one on observability as well. But testing's definitely been a really important part of it. And as someone that's a big interest of, as the author of Catch and Catch 2, I've been following that very closely. And yes, it's some really good stuff. So if you haven't been listening to Two's Complement, definitely listen to that. So it's a really useful perspective on it. One of the episodes, not the last one, the one before, actually had James Grenning on as a guest. James was one of the original Agile Manifesto signatories, although he had a slightly different story about it in the episode. You'll have to listen to that to find out. And they also talk about things like design patterns and other areas that are not specific to a language. They're more about the craft of building software, which is a nice lead-in actually to another podcast. So CPP Cast, the last episode as we record this was with Klaus Igelberger, talking about the solid design principles. It's another one that I really appreciate everything Klaus has to say and agree with most of it, but not all. We've got some slightly different opinions on some things, so we'll have to do something to counter that at some point. But definitely worth listening to that episode if you don't listen to CPP Cast regularly, because I think this is something that we tend not to talk about as much in C++ circles as maybe some other language circles, is the actual design principles. Particularly the solid principles, they tend to be much more associated with object orientation, which of course C++ does, but it's not something that we tend to embrace as like a first-class thing so much these days. So people shy away from things like the solid principles, and really they shouldn't. There's a lot of good stuff in there. I just think we need to maybe qualify it a little bit more. Klaus does an excellent job of that, but yeah, that's definitely one to listen to as well.
Yeah, that sounds really interesting. I unfortunately didn't manage to listen to that, probably because my kids' birthday interrupted me from my regular flow of listening to CPP Cast, but I will definitely yeah.
Yeah, well, with all these new podcasts around, it's actually quite hard to keep up these days.
Oh yeah, that's true. Yeah, but let's maybe continue more about the testing topics. So, because in February, we'll do a webinar with Clare. And that all started with the webinar which we did in the past with Arne Mertz. You probably know him from Simplify C++ blog. And he also did a webinar on like refactoring C++ code together with us in JetBrains. And there he stated that tests are essential things to have prior to refactoring the code, because you have to check how the things are going after you actually refactor the code. And they are necessary as they are the only way to confirm you're like not breaking the code. But then came a very natural question from the audience, like, what if there are no tests to easily check the changes introduced by refactorings? And a very good question, I would say. And so together with Clare, we've captured actually this question, and she's a very right person to answer that. As a core contributor to the approval tests for C++ library, and a speaker which often actually speaks about these kind of related techniques, how to, cover dinosaurs, the legacy code with tests, and to introduce them smoothly. So she will try to present her answer, and me and Phil will be like hosting and trying to assist and maybe ask more questions about the dinosaurs and the tests. And so the webinar is planned for February 16. You can find the link in the notes how to like register and add it to your calendar. We will be streaming on YouTube, but we do recommend to register, to get all the reminders and the follow-ups, just not to miss it. So yeah, that's about the webinar.
Interestingly, both Claire and Klaus, who we talked about a moment ago, they are both also trainers who talk about these subjects in 1 or 2 day workshops, because there is a lot of depth to this material. So definitely attend this webinar to get a taste for it. But if you really want to learn this stuff in depth, do go to these workshops. They are definitely worthwhile. There's a lot you can get out of them from the experts.
Yeah, hopefully you'll have some kind of maybe approval testing or something like that, testing workshop at C++ and C.
Well, none of them have been approved yet, but that's definitely on the cards. Yeah, so talking of being on the cards, so here's an image. If you're watching on YouTube or you've got a podcast player that can show images, it should be showing now. So this is obviously ray traced, but how was this produced? Do you know, Anastasia?
Yeah, like I know, and I'm really, really surprised because this is done with the CMake, this is really pure fun. So like in a bit less than 600 lines of code in a simple CMake list.txt, they presented a true ray tracer, which actually shows you this. And, the CMake language is often blamed for being inconvenient and leading to issues. And it's it's hard. The documentation is improving, but it's still not ideal. And the people are still having hard times dealing with the CMake. And what they did a full ray tracer written in CMake. And it's really interesting to read through about how it was done, because there are a few challenges there. For example, like CMake math commands, they're nice, but only can do integers. So they were doing fixed point arithmetics, and also they were like kind of computing square roots, vector operations, all that stuff in pure CMake, And they even did a multi-core rendering invoking subprocesses via the execute process command in CMake. So wow, that's actually big. I wonder what else can be done in CMake. Is it the next universal programming language for us? What do you think?
Well, I'm old enough to remember the days that we were really impressed that you could do the Fibonacci sequence in templates in C++, but in a compile time. But now, you can do ray tracing with a build system. I think it just goes to show that anything that is Turing complete can pretty much compute anything.
Yeah, that's true. Actually, CMake really sounds like a true language these days, because I remember the times the debugger for CMake was introduced. I don't know the current shape of it, so I think the author hasn't moved forward with that. But I remember there was a debugger. There was even a plugin for IntelliJ-based tools for CMake, and I was like, at that time, the idea of debugging the CMake script sounded crazy to me. But now I think okay, if I'm gonna start writing a ray tracer in CMake, I probably need a debugger. Then maybe a unit testing framework. That's more for you, Phil.
Yeah, well, I think you definitely need a visualizer.
Yeah, that's true. But yeah, these things these days kind of crazy. But I really like the result. Looks nice.
Maybe the speed ups at link time will help.
Yeah. But anyway, yeah, I think that's a nice picture to wrap up. What do you think?
Mm-hmm. Absolutely. Well, we've got the ball rolling, and we've ended up with a rolling ball. So, yep, I think that's a wrap for January. We're into February now. We better get started on the next one, I think. So, in the meantime,
yeah, that's true.
We'll say goodbye and see you next time.
Yeah, see you next time.